How are you guys? Are you excited? Let's do a question now. So the question is like this. Let me show the window. I was working on this question of CSES. The question is of road construction. It is said here that there are initially n cities and initially no road is between them. Okay. However, every day a new road will be constructed and there would be a total of m road. So a component is a group of cities where there is a route between any two cities using the roads. After each day, your task is to find the number of components and the size of the largest component. Right. So what it's saying in the input is first we are inputting n and m. So let me just take it here. And just for the reference, let's yeah. So n and m are our input, where n is the number of cities and m is the number of roads. Sorry for the bad writing. The next m lines are such follows that there would be two integers in the next line a and b. A and b would denote that there is a road in between a and b. Okay. So what I would do is I would just think of it like this. Let's think of a subtask of this one, like 5 3. So if the input is 5 3, okay, so what would happen is I have 5 nodes because n is the number of nodes. So n is 5 and m is 3. Wait a second. Yeah. Now here I have one which is connected to 2, and I also have 3 here, 4 here, and 5 here. The size of the largest component is 2 and number of components in total is 4. So our reply would be 4 and the size would be 2. Right. Now another one, where joining the path between 1 and 3, I will just connect 1 and 3. Now we can see the number of components are 5 here, 4 here, and 1 to 3 as a whole component. So number of components is 3 and the size of the biggest component is also 3. About 4 to 5 we have this one. Right. Now we can see the number of components here is 1 2 3, 1 and 5 4 2. Number of components 2 and the size of the biggest component remains 3. So what I can do for this question is I can follow the disjoint set union approach and create all these connected components at every iteration, and for every iteration I will just find the maximum size of the certain component. Now for coding part, I will go to my VS Code. Right. Okay. CSES. And the problem is road construction. Now let's start coding. Cool. I erase this. Insert a template here. So what are the input? The first input are L and M. So N and M. So just input these guys. Say in N and M. Now let me create a class for the disjoint union. Disjoint set union. So what it would have is, oops, class disjoint set union, and what it would have in the private one is number of vertices. So just write it here as vertices. Then what I would have a vector for parents. It will denote the parent of each element. Then I would have a vector for size. It would denote the size of the current component in which this node, in which a certain node is the representative of that component. Now I will just write the I will first write the constructor. In constructor, I will take in input number of nodes and input. Then I will initialize the vertices n. Then I will initialize the parents. So first, mark the size of the vector as n. Then for initially, since okay, so number of nodes are from 1 to n, right? So I will just make +1 for in order to have the last element as n. Then I will start from 0 to n plus 1, and initially what we can say is if we are to emphasize the drawing, every element would be its own parent. Right. Then when we are joining 1 and 2, so we would have 1 2 as the parent of 2, and 3 would remain like this, 4 would remain like this, and 5 would remain like this. Then I would have 1 and 3. So what I would do it, how I will join, since the size of 3 is less than the size of the component 1 2, so I will join 3 to this component. Then what I would have is 1 like this, so 2's representative would be 1, and 3's representative would also be 1, and 4 would remain here, 5 will remain here. So I will follow this pattern. So initial parents would be the nodes itself. So after this, since I have initialized the parents, I will initialize the size as well. So the length of the size would be initially n plus 1, and the size would be n1 for each of the node, because the initial size would be the node itself, so it would be 1 only. Now after all of this, I will create the find function for the disjoint set union. What find will do it will find the parent, ultimate parent of the current node. So just think of it like this. I am joining an x node here, so find will return me the ultimate parent of x, which would be 1, using path compression. Yeah, so let me just write the find method. Find for a current node I. So what could happen is, suppose 1 is the representative element, yeah. So if I is the representative element, then simply I will return the I itself. Like if 1 is the representative element, then parent of 1 would also be 1, then simply I will return 1. Else if it happens that the parent of x is not x, it's some other value, then I will do path compression here. So I will just write if I is not equals to parents of I, then parents of I would be equals to find the ultimate parent of, find the representative element for parents of I. So yeah, now after this I will return the resultant value which I got from this equation. Okay, now I will write the union structure. So union, I will in union I will introduce the hij. So yeah, just write it like this. Find the ultimate parent of our I. So I will find it using parent of I, and yeah, I have to initialize it as int. Then int root of j is equals to find for j. Now what I will do it, I will find the size of I. So int size of I is equals to size of root of I, and also int size of j would be equal to root of j. After all this, what I would do it, if size of I is less than size of j, then what I will do it, if size of I is less than size of j, then I will join the smaller element to the bigger element, smaller element to the bigger element. What? So the equation would be like this, that parent of j would be equals to the ultimate parent of I, and I will also increment the size of j. So size of root, sorry, parent of I would be, because we are joining the I now, so the parent of I will change, is equals to root of j, and root of j would be increased by the size of root of I. So the number of nodes in the smaller component will be used to increment the size of the component containing the node j. Okay. What I can write it, if root of I is equals to root of j, then there is no use, just skip all this bunch of stuff which I'm doing in the down, else just do the reverse of it. Parent of j would be equals to root of I, and size of root of I would be incremented by root of size of root j. So this much is I have written. Let's see where am I wrong, where could I be wrong. So the input is like that, right? So I don't need this much. What I need is n only and m only. Input n, input m. Create a disjoint class D containing number of vertices n. Then for each of the edges, I will loop over them, and what I will do is I will take two nodes A and B and input it here, like C in A and C in B, C in A and C in B. Then after that I will do a union, like disjoint union of A and B, A and B. After doing the union, what else I have to find? I have to find the number of components and the size of the largest component. So number of components, for finding the number of components, so ll num is equals to 0 and size equals to 1 itself. So what I will do is I will erase this one. Yeah, there is no need for this one. It will make the problem solving much easier now because I don't have to create new functions for it, and this just shortcut, right? So number of components can the components can be represented by the representative element. So suppose I is the representative element of component Ci. This would imply that parent of I is equals to I itself. So wherever I is equals to parent of I, that would be a new component. So just like that, I will loop over all these sizes. Okay, and if d dot parents of I, yeah, it's like this, right? We are working on this because the nodes are from 1 to n. So if parents of I is equals to I, then I will just increment the number of components. And also what I will do is I will find the size of each component. So size would be maximum of size and d dot size of the ith component. Later on, I will return the number of components and also the size. So this is the resultant value. Let me compile it. Road construction. First value is 5 and 3. The another is 1 and 2. Then another is 1 and 3. Then another is 4 and 5. Okay, something is wrong here. Oh, it wasn't the equality operator. So let me, silly mistake. So 5 3 1 2, then 1 3, yeah, and what else, 4 5, right? Maybe I will submit it. Kinda submitted. Road construction. Let's cross our finger and see if it gets accepted or not. TLE, wrong answer. Why would that be wrong? So the input is what? Let me see the input. Got it. The correct output would be this, and what I've gotten is something else. What is the correct output? Correct output is that one. I will just run my code here. This fellow. Okay, so 1 2 9. Ten, 9, 8, 9, 9, 2, then 7, 8, 8, 3, then 7 3 7 3, it was 2 3. So something is wrong definitely, because it's not coming like how it should. What could I do, man? I can make a I can make two functions, add two functions here, like or initialize two variables here, like number of components and max size. In order to save on the complexity, the components initially would be equals to number of n, and max size would be equals to 1. Right. Now, whenever I'm trying to do a union, doing a union will do what? Whenever two, okay, so whenever I'm joining two components, like component 1 and component 2, that is, I'm doing a union of two different components, the number of components will decrease by a order of -1, by order of 1, decrease by order of 1. So I will just introduce the step here, like if I'm joining two different components, then the number of components will also decrease. Components will decrease. Similarly, in here as well, number of components will decrease. And the max size would also get updated. Max size would be max of max size and size of root j. And here it would be root I. Now, rather than finding making a for loop here, I will just see out the d dot components here and d dot max size here. Let's hope this code holds to the standard G++ and our road construction. Indeed. Now the test cases are here. So the initial problem had a test case on 5 3 5 3 1 2 1 3, sorry, and 4 and 5. Right. Now if I just submit it again, because why not, I'm not getting my answer blocked by somebody, something. Go on, show me. Okay, so there is no TLE here. That's a good thing. Means I'm going through the right way, not wrong way, what I'm saying. Now there are some edge cases which I'm not able to get rid of, like where was it, the input. Why is it wrong though, man? I can't just, let me see where I could be wrong. The number of vertices are there, parents are there, okay, parents are there. Size is also initially 1, the components are okay, maximum size we are finding the ultimate parent of I and ultimate parent of j. The size of I is like this, size of j is like this. If ultimate parent of these two guys are equal, means they are from the same component, nothing I will do. But in this one, if they are from different component, then I will add the smaller component onto the bigger component, and I will update the max size and also decrement the component because we are merging two components together. Okay, so on and so good, but nonetheless, nonetheless, user output, I'm getting 050505, and what I need is 292929. Dangerous, to say the least. Nothing is all right here. 9283737364554538, then 292929 is it was going on. We need to keep that the way it is. I mean, how can that be zero? How can the number of components be zero? Am I insane? My code is bad somewhere. I don't know how it could happen. Initially, the number of components is n. The parents are also good. Size is also good. If I is not equals to parent of I have to do the part compression. Size is also good. Do I debug it? Yeah, I need to debug it. I'm going to debug this. What I need is the input them. Okay, this is the input. Let me start the debugger. Let me press the endpoints. Now, just loop over it. So, 1020. Just copy this whole thing and paste here. Now, currently, my parents are my parents. Indeed. Size is 2. So, let me draw this as well. So, if I just keep this here, and let me draw it like this: 9 here, 5 here. So what my code has done it has rooted parent of, okay, so what my code has done it has created 9 as the parent of 5. So 9 would be here, 5 would be here. Okay, everything is good now. Later on, for the next pair, 9 6. Cool. So 5 9 again, 5 9. So 5 9, does that changes anything? 5 here, 9 here, 9 here. The parent of 9 would be this 9. The parent of 5 would be 5. So do nothing if those guys are equal. Wait, 8 10, right? 8 10. So I'm creating 8 here, then 10 here. After this, I'm joining 5 and 3. I'm joining 5 and 3. So 3's parent is 3, 5's parent is 5. Okay. So one is left out, two is left out, four is left out. So number of components 1, 2, 3, 4. Wait a second. 7. 7 are missing. Yeah. Everything is good. 9, 4. Okay, cool. Now I'm joining 5, 2. Okay, joining 5, 2. So two's ultimate parent would be 9, and our 5, 2 na. So what they call it? Increment by 5. So okay, the size is 5, and the total number of components will also decrease because here 1, 2, 3, 4, 5. Cool. Now what I'm joining is we are joining 10 and 8. If 10 and 8 are being joined, so nothing would change according to me. Max size would remain 5. Yeah, nothing has changed. Then we are joining 10 and 7. If we are to join 10 and 7, then the ultimate parent of 7 would also be 8, which is the ultimate parent of 10. So let's see. Let's focus on this guy. Okay. Yeah. So 8, good. Number of component will decrease. So 7 here. Okay, size of 7 will remain that same. Component will be 4. So 1, 2, 3, 4. Cool. Now let me see the discrepancy. Like 5, 5, it's good. 4, 5, then I need 3, 8, 3, 8. So after this, what I'm trying to input is 5, 9. 5, 9 would change nothing. Has nothing changed? Yeah, nothing changed. Then I am inputting 10, 9. If I am to join 10, 9, then the parent of 8 would also become 9. If I am careful about this, parent of 8 would also become parent of 10 has become 9. Okay. Weird. Oh, so I need to update this value is like this. Parent. Yeah. That's the only way to think about it in the right terms. That was the mistake here. Now let's try submitting again because I wasn't paying attention or whatever. So everything looks good. Let me try submitting it again. Browse, select, submit, select, submit. Let's see. I mean, this was the easy question. Nothing hard about it. Yeah, it got accepted. Thank God. So that's it for today. See you tomorrow.